This is an update on the progress on the Orwell computer. Now it has a housing, a case. I decided the hardware was pretty much finalized, so I better get busy and build an actual box for him. So what I came up with is a custom made steel box. This is all steel with timber ends. These are actually oak, recycled from an old dresser picked up off the side of the road. A friend of mine rescued it for me and I stripped it down and reused some of the timber for that. I also got a slightly bigger small LCD monitor that I can use. That just sort of sits on top there. It's not attached in any way. These monitors are used as reversing monitors and media monitors in cars. So they actually come with RCA for composite video in, and this one actually does VGA as well, which is kind of nice. So Orwell outputs composite videos, so that's all I'm using on this. So the case is steel, it's fairly hefty, weighs a bit. Look around the back here, you can see I have a panel set into the back. This is power coming in, and at the moment I'm just using a 12 volt plug-in power supply, 1 amp power supply. We have a fuse just to protect the machine in case the power's plugged in backwards or something. This is the reset button available on the back, and then in the back here we have several D connectors. The bottom one is general purpose I/O connected to the I/O daughter board inside Orwell. This middle one is an analog joystick port, and that also goes to the analog inputs on the I/O board. So I have two A to D converters, and then they're being fed into a 6522 VIA chip, and then that's connected to the computer. So the joystick just plugs in there. Or you could use those analog ports for any sort of analog voltage coming in. The top one is just a standard sort of serial port. It goes in there. Over here, this is the composite video out, and so I just have the monitor plugged into that, just through a little adapter. We also have external audio out. It does have a built-in speaker, which is why there are some holes here, and there's a small amplifier in there to drive the speaker. But you can connect up an external audio amplifier if you like. So the idea being that you can plug this into a normal television. So you would just plug it into the video and plug the sound into there. The other thing I'm doing is driving the screen through this extra power connector. So inside the box there are actually two regulators. The first one regulates down to 12 volts, and that's what's being fed back out here to the monitor. And the second one regulates down to 5 volts, which is what the computer itself uses. This little blue box is the joystick I made. I think I wrote that up on my blog. This is kind of a temporary thing. I want to build a nicer housing for it, maybe a little metal box. And I'd like to get an older joystick mechanism, more the kind that was used in old radio control transmitters, with the little stick. But this one's just one of those little PlayStation style ones, and that seems to work pretty well for now. On the front we have the keyboard, of course. It's actually quite a nice keyboard. It's got good proper sprung clicky keys. We have the volume control. We have my output LEDs, which are basically just connected to a memory location. And I tend to use those for debugging, so you can just poke any value into that memory location and the value will show up on these LEDs. We have the power LED and a power switch, and a nice little custom etched label. If we turn it on, it's going to be a bit tricky to actually see the screen. It's very hard to focus on that, of course, but this is now running in 80 columns, just simple black and white. This first startup message is saying cold or warm start, so we do a cold start. And it just comes back with how many bytes are free and a little bit of a message. So the serial port I actually have connected to my laptop, and to transfer data to and fro I just use a serial program running on the laptop that just talks down to the computer here. So we can demonstrate a few things. If we put it into loading mode, it beeps, and then we can send a file from here. And then it beeps again when it finishes loading. The way I do that is with a Control-C at the end of the file. And the computer actually detects the Control-C, because you can do that through the keyboard, and it jumps out of loading mode. We can list the output, and we can run this program. And this is just my very annoying random shapes drawn on the screen, playing random noises sort of program. It was just a good little test program. But you can see here how the debug LEDs work, just by displaying whatever value happens to be poked into them at the time. We can stop this. The other thing I can demonstrate is how the joystick works. So if we to load a new file, and we can send that. The sending is quite fast. It's actually transmitting at 19200 baud. I used to have a problem though, where often if you tried to send the file too quickly, the machine would kind of lose its brains. It would just stop working. And at first I thought it was some sort of error to do with the actual serial data transfer itself. But I think what was actually happening, I kind of worked out in the end, is when I'm doing a serial transfer, what I'm actually doing is instead of taking the input from the keyboard, I am taking it straight from the serial port. Now the thing with a machine like this is every time you enter a line of text, it has to interpret it. It basically parses the line to figure out what it is and what it needs to do with it. And so if the line begins with a line number, it'll treat it as a line of code, a line of program. If it doesn't have a line number, it'll just treat it as a command, and it'll run in what's called direct mode. And what I think was happening is that processing is quite slow compared to the serial port. And I think even with my circular buffer, I was overflowing the capability of the machine, and it would start effectively typing rubbish into the command line. And this was causing all sorts of weird things to happen. So in the end, I tried basically using the flow control that's already built into the machine to stop the serial port. Once it gets a full line, it'll stop the serial port temporarily until it's processed that line, and then it'll continue again. And that seems to have fixed the problem. So now it'll transmit data at the full speed and pause where necessary to actually do the processing on it, and then it'll just start up again. So we should have a program there. If we run this one is basically just, turn that down a little bit, reading from the joystick and plotting the position on the screen. And it's also using the coordinates to drive the sound, which is kind of annoying. But the debug LEDs are showing the y-axis value. That sort of bleeping is the jitter on the analog to digital converter. There's a little bit of noise there. So if we turn the volume down, the other thing I can demonstrate is the way the joystick works. So that's just straight y-axis. You can see that the bottom bit is set there. Now, because I didn't have any spare inputs, I kind of cheated with the joystick a bit. I sort of did a little bit of a hack to get the buttons in there, and the button is actually hooked up to that bottom bit. So if you push the button, you can see that the bottom bit goes on and off. And I basically use that to detect the joystick buttons. Losing that bottom bit doesn't seem to affect the the accuracy of the joystick at all, because they're not that accurate to start with, so it doesn't really matter. It does mean basically you get across the scale, you'll get odd or even values depending on whether or not the button is pressed, but it's easy enough to handle that sort of thing in software. So if we break out of that, it'll keep playing the sound, because the last thing it did was poke values into the register to play the sound. So we can hit the reset button. Now the reset will do either a cold start or a warm start. You get to choose. Cold start refreshes the memory and starts completely from scratch. A warm start will just reset everything but not clear the memory. So if we clear the screen, we can see that that program is still there. That's very handy when you're debugging, of course. You can reset it, but you don't lose your program. So that's basically it. That's how the machine works. The next thing I want to do with it is I do want to keep doing the Usborne books reviews. I've got a whole bunch of those to go through. But I've also been using the machine to as a follow-on from my Enigma watch project. So after building an Enigma machine, the next thing you really want to do is build a Turing bomb. That was actually my plan originally, and I had to build the Enigma machine first. So that's where that came about. So the plan now is to code the Turing bomb using this machine in BASIC. Now I'm not even sure that's going to be possible, because the machine's quite complicated and it's quite hard to understand. I'm not sure if I fully understand it yet. So the idea of the exercise is that if I can write the code for it, it proves to myself that I know how it works. So that's what I've been doing. I've been slowly working on that. And I've done a little bit of it so far, so we can load that up. Now this has quite a bit of text, so in here, if we want to do a new program, we can say new, which resets the memory. We load, and then if we go over here, we can send this file. Now this file is a little bit bigger. The beepings there are because I've got some files over the maximum line length because of comments in them. So that's now finished. So this is just the very, very start of the Turing-Welchman bomb. If we run this, all it's actually doing is given a rotor start position and an input letter. It's just stepping through every single combination going through that letter with those three rotors. You can't see what it's saying, but you can see it stepping through. So that's not very far down the path of actually having a working machine, but it's a start. So the interesting thing is that's going about as fast as a mechanical Turing bomb would go. So I've got a funny feeling that even if I do get a simulation running, it's going to be slower than the original, which isn't surprising considering it's running on an 8-bit homemade machine, running at 1 megahertz, running BASIC. So I think if I can get it to work, it'll still be quite an achievement. And that's what I'll do next. And then we can just power this off.